Okay, so let's see if we can straighten out Avin's made-up problem and see if it's appropriately A-level. So Avin says we should rewrite cosine of log of x squared with a cosine squared of something. And then he actually was nice enough to give us the hint that we should maybe think about the double angle formula and log rules. Okay, cool. I think probably this rides to A-level. Yeah, sure. Because you're kind of incorporating two things that we've never really put together, right? Ooh. Like I have to put log rules and trig formulas together. This is, however confusing, not particularly difficult though. So what do I start with?
You can name the 2 out of x squared.
Perfect. There's a log rule that says I can take this 2, right? And pull it where?
Put it in front of the log.
At the front of the log. Okay, so I can use a log rule, right? So log rule will get me to cosine of 2 log of x, right? And then what?
You can treat log as theta, right?
Yeah, so you can kind of think about, okay, all of log of x here I'm going to think about as the angle theta, right? So then I'm going to do double angle, right? And so I have like cosine of 2 theta is what?
Something squared.
Okay, so maybe I should over here try to recall cosine of 2 theta. So cosine of 2 theta is cosine of theta plus theta, right? So I could go bust out the sum of angles identity, which is really where everything comes from, right? So this would be what? You guys remember the sum of angles identity for cosine?
Isn't it the cosines multiplied together plus the sines
Yeah,
multiplied together?
cosines minus sines. So this would be cosine of the first angle, cosine of the second angle, minus sine of the first angle, sine of the second angle. But everything's all thetas anyway, right? Okay, so I got cosine squared theta minus sine squared theta. Now what should you avoid falling for here?
The Pythagorean identity.
Yeah, don't fall for, this is not the Pythagorean identity, right? Pythagorean identity has a plus in the middle. But I can use the Pythagorean identity to make this guy a little bit easier, right? They told me to write this as cosine squared of something, right? So maybe I should try to get rid of this sine squared. So what's sine squared? Yeah, it's 1 minus cosine squared, right, from the Pythagorean identity. So this is cosine squared of theta minus 1 minus cosine squared of theta. So I think that gets me cosine squared of theta. Ooh, wait, what?
2 cosine squared theta.
Good, 2 cosine squared of theta minus 1. Cool. So now I need to put that over here. So I got a 2, right? Cosine squared of what? Yeah, of theta minus 1. But what the hell was theta? Theta was log of x. Cool. So I think that's about the best I can do in terms of rewrite. Cool. So I found this new trig identity. It's kind of weird. It says that if you happen to have cosine of log of x squared, that you can rewrite it as 2 cosine squared of log x minus 1. Weird. This falls under the category of things that are true but are not often useful. Right? This one I have a little bit of weirdness with. I don't even really know like why you would log an angle. You guys see that? that feels a little funny to me. It's maybe not necessarily wrong. It just feels weird. Cool with that?
Bad vibes.
Yeah, just weird vibes. Like, I'm not sure of a physical situation in which that might come up. There might be one. I don't know. I definitely do not.
What happened to the other cosine?
What other cosine?
The blue, I think it is.
Like,
This other cosine?
no, it's like
No.
there's a cosine. Oh, yeah, because it's split. Never mind. I get it.
Cool. Good talk.
Sorry.
I don't know where you were confused, but I'm glad I cleared it up. All right. So then there's this other thing, which Avin says we should evaluate at x as 5 pi over 12. That I think we're totally screwed on. The reason for me thinking that we're totally screwed on that is that I don't know how to log 5 pi over 12 conveniently.
I miswrote things.
So I think you could modify this into a question that would make sense if you said, instead of evaluate at x is 5 pi over 12, I think you could do evaluate at x is 10 to the 5 pi over 12 or something.
Yeah, that's what I meant to do. Something like that.
Yeah, something like this. This could actually work, right? Because you can plug it in, you'll get 5 pi over 6 in the exponent of a 10, then you'll log it, so you'll get the 5 pi over 6, and then maybe you have a chance of cosigning 5 pi over 6.
You mean 12, not 6.
I meant 6. You're squaring, right?
Okay.
So you're going to square this thing, which will get you 10 to the 5 pi over 6. That would sort of make sense. I don't think this trig or this kind of trig identity we've built is going to help you a ton doing that, but what else? Cool.